Okay, let's go on to the next example. Example 4 says finding the slope of a graph implicitly. So remember, a derivative is the slope of the graph. So if it says find the slope of the tangent line, all they're asking for, of course, is dy dx, except notice they're asking it at a point square root 2, and then the y value is -1 over root 2. Well, this is really cool because before we used to find the derivative and then plug in the x value. Well, now we're going to be finding the derivative and have to plug in both x and y values. So kind of a neat little example here. Let's go ahead and give it a try. So what do? We start off with the function x squared plus 4y squared equals 4. And what we want to do is we want to take the derivative with respect to x of both sides of the equation. Okay, so what's the derivative of x squared? It's simply 2x. What's the derivative of 4y squared? Well, 4 would be 4 times 2y to the first, but then you need the y prime, right? And the derivative of 4 is simply 0. So if I clean that up, it would be 2x plus 8y prime equals 0. I solve for y prime, so I'm going to subtract 2x from both sides. When I do that, I end up with 8y prime equals -2x. Now I need to isolate, I have isolated y prime, but I need to get it completely by itself, so I'm going to have to divide by 8y. I'm going to do some simplification. I'm getting y prime equals, well, the 2 and the 8 are going to simplify into a 1 and a 4, right? So I'm getting, what, -x over 4y? So this is what my slope would be at any given point, -x over 4y. But we have a very specific point. We have at the point root 2 comma -1 over root 2. So what are we going to do? Well, we're going to say y prime equals -x, which would be -square root 2, all over 4 times y, which was -1 over root 2. Okay? Go ahead and put that in your calculator, or you could try inverting and multiplying and simplifying, but look, I just put it in my calculator to simplify, and I get a total of +1/2. The negative divided by a negative gave me a +1/2. So what is the slope of that equation? Notice it's not a function anymore, because we can't solve for y as a function of x. So this isn't a function anymore. In fact, I believe this is an ellipse is what this is, okay? But we found the derivative of the tangent line at that given point. In fact, it is an ellipse. I encourage you to graph it. Graph it on Desmos. The ellipse looks something like this right here. And what we just did is we found, here's the point, root 2 -1/2, or -1 over root 2. What we just did is found the slope of this tangent line right here. The slope of that line is 1/2. So kind of cool to see what we're doing now for more complicated equations, not just functions. Let's look at example 5. Very similar problem here. It says find or determine the slope of the graph of 3 times x squared plus y squared quantity squared equals 100xy at the point 3, 1. So let's go ahead. What we need to do, again, is take the derivative with respect to x of both sides. We're going to have a lot of chain rule here, so we've got to be careful. So when we take the derivative of the left-hand side, the 3 stays there. We're going to use the chain rule, so we have to drop the power. That's the 2. Then we have the inside stays the same, so that would be x squared plus y squared raised to the first power. But then we need to multiply that times the derivative of the inside, x squared plus y squared, the derivative of that. Okay, we'll do that in a second. And then that's going to be equal to, well, again, here we have a product rule. 100xy is a product rule where the first function is 100x and the second function is y. So if we want to do the derivative of that, it's going to be the first, which is 100x, times the derivative of the second. The derivative of y would be y prime, plus the second, which is y, times the derivative of the first. The derivative of 100x is 100. So let's go back in and clean this up. What's the derivative of x squared plus y squared? Well, it would be 2x plus the derivative of y squared is 2y y prime. Okay, So I need to clean this up. I'm going to do this in a couple of steps because I don't want to mess this up. 3 times 2 is 6, and then what I'm going to do is distribute that 6 through the x squared and the y squared. So what I have here is 6x squared plus 6y squared. That's my first, and then when I found the derivative, that was 2x plus 2y, y prime. And on the right, I have 100x y prime plus 100y, right? Okay, now what do I do? Well, I'm going to go ahead and distribute the 6x squared through, and then I'm going to distribute the 6y squared through. Let's see what we get. 6x squared times 2x would be a 12x cubed. 6x squared times 2y, y prime would be a 12x squared y, y prime. And then we have the 6y squared times 2x, so that would be plus 12x y squared. And then 6y squared times 2y, y prime would be plus 12. Then it would be y cubed y prime. And on the right again we have 100x y prime plus 100y. Whew, this is a mess, but that's okay. Let's keep on going. So everything with a y prime I want on the left. So I'm going to subtract off 100x y prime from both sides. And then I'm going to move everything else to the right. So I'm going to subtract off 12x cubed. I'm going to subtract off 12xy squared. And that looks it for me, okay? So I'm going to cancel these out. And let's see what we end up with. On the left, I have minus 100x y prime plus 12x squared y, y prime plus 12y cubed y prime. And then on the right, what do I have? Looks like I have 100y minus 12x cubed minus 12x y squared. Okay, let's keep going. I'm going to factor out a y on the left-hand side, or sorry, y prime on the left-hand side. That was the whole reason of isolating all those terms. So what would be left? The first term would be minus 100x. The second term would be plus 12x squared y. The third term would be plus 12y cubed. And then on the right again, we have the 100y minus 12x cubed minus 12xy squared. Last step for solving for y prime, I'm going to divide both sides by negative 100x plus 12x squared y plus 12y cubed on both sides. And I'm going to be left with, this looks really nasty, let me write it up top here. We're going to have y prime equals 100y minus 12x cubed minus 12xy squared all over negative 100x plus 12x squared y plus 12y cubed. What a dang mess. Now, could we simplify? I mean, certainly I see at least a 2 in common. I see a 4 in common. I don't friggin' care. Look, simplification is not the point in this problem, and I don't care about simplification when it comes to implicit differentiation. Only when it comes to implicit differentiation, but I do not need you to simplify this. In particular, we need to look at this when x equals 3 and y equals 1. So we need to plug in the values here. So here we'd have y prime equals 100 times y, which is 1. Minus 12 times x cubed, which would be 3 cubed, minus 12 times x, which is 3, y squared, which would be 1 squared, all over negative 100 times x, which is 3, plus 12 times x, which is 3 squared, times y, which is 1, plus 12 times y, which is 1 cubed. So I'm plugging in those numbers. No way in heck I'm doing that by hand. Go ahead and plug that in. Tell me what y prime is in this case when you evaluate it. After plugging it into my calculator, I'm getting 13/9. I hope you guys are getting the same. I hope I didn't make an error in there. Okay, so that's implicit differentiation. That's a pretty nasty looking formula. I'm not gonna lie, that's what it is though. So sometimes you just gotta get through it, get through the algebra. Remember, for derivatives, how much calculus did we actually do? After we were done with the first step, this was the only step of calculus. Every single other step we see here was just algebra. Okay, let's look at number 6 here. It says find dy dx implicitly for the equation sine y equals x. So again, what do? You always want to find the derivative with respect to x of both sides of the equation. So what is the derivative of sine y? Remember, we want to treat this just like a chain rule, like it was sine of u. So remember, the derivative of the sine of u is cosine of u times u prime, but in this case it's a y, so it's going to be cosine of y times y prime. The derivative of x on the right hand side is just a 1. We solve both sides for for y prime by dividing by cosine of y. So divide both sides by cosine of y, and we end up with y prime equals 1 over cosine of y. And there it is right there. Of course, this derivative is not defined everywhere because cosine of y cannot equal 0. So if you want to look further into this problem, in the e-text they go into a definition of when would this function actually be defined. Okay? So even further, what this does, now look, I'm perfectly fine with this answer for this problem, but I just wanted to kind of give you a little bit of an oomph into what we're going to be doing into the next section. So first of all, would you agree with me that sine squared y plus cosine squared y equals 1? Hopefully you remember your Pythagorean identities. Well, what I could do is subtract sine squared y from both sides, and I'd have cosine squared y equals 1 minus sine squared of y. So hopefully you believe that's true as well. And then I could take the square roots of both sides. We would have plus or minus, but I'm going to look at cosine of y would be equal to the square root of 1 minus sine squared of y is what I'm looking at here. Now, why would I do that? Well, if you look back at the original part here, we know that sine of y is equal to x. So sine squared of y would have to equal x squared. Let me go ahead and underline that in purple, right? So that's the substitution that I'm making. So we could say cosine of y equals the square root of 1 minus x squared. So if you kept on going on this problem, you could have said, or this is equal to 1 over the square root of 1 minus x squared. Would have I expected you to do that on this problem? Absolutely not. But they do talk about this in the textbook, and the reason they talk about this in the textbooks is because we are going to be going on to inverse trig functions. And these are the exact types of substitutions you're going to have to make to solve for inverse trig derivatives of inverse trig functions. So way more in depth than you guys needed. 1 over cosine y would have been perfectly fine in this case, but I did want to show you where that substitution is coming from and what they did in the e-text if you were following along.